Here I have to have two jobs. One is to make you understand the statistics. The other one is just after the lunch, post lunch, you will be in that la 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 la. So we will see how it goes. So I'll try to give some basic introduction to statistics and probability. So what is this? Why statistics and probability? I hope you all studied somewhere, isn't it? I hope you have heard the terms statistics and probabilities. Why we need that, or what is that, first of all? Any? I hope you would have studied in your mathematics, in your undergraduates as well as in the postgraduate, isn't it? So, is it the only mathematics you have studied, or you have studied something else as well? What are the things you have studied in your mathematics? Huh? Probability, statistics, any of it is there. Apart from this probability and statistics, anything else you have studied? Stand what? No, no, no. Like I'm talking apart from statistics and probability, not in probability and statistics. Integration, differentiation, matrix, and all those things, isn't it? So how they are different from the statistics? Are like if we look at what are the different mathematical methods. So let us say I wanted to calculate the area of this particular room. Okay. So how do I calculate? It's a kind of a rectangle, isn't it? If I measure the length and breadth, I would be able to calculate the area, isn't it? So is that a statistical method? One way, but what are the other ways of like it's a mathematics, right? So what are the other methods, mathematical methods we have? Obviously, calculating area is not a statistical method. Is integration, like doing integration, is it a statistical method? No. What method is it? Deterministic or okay, the integration we do it in a different ways, isn't it? How do you remember? Like one is like the basic, let us say x, if I want to integrate, that is what is integration of x? X to the square by 2. Okay? But that is one way. Also, you would have studied some methods like trapezoidal rule, Simpson's rule, and something like that, isn't it? What is that and what is this? So we are doing same integration, isn't it? No, 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 it's not possibility. We are going to come up with the same value. Let us say x square by 2. If I substitute x, some value of x, I'll get same number in even with analytical method. Next one, whatever we call it, it's like sequence rule and all of them are numerical method. Okay, we are going to get the same number, but the difference is one, we do it that's analytical method. The other one is numerical method because numerical analytical method cannot be coded in computer. So if I wanted to solve something in computer, I need to go for numerical method. And second thing is that for some of the equations, you don't have analytical solution. So therefore, we go for numerical solution. Now, what is the statistical? So here we are not talking about the solution of same integration and differentiation. So here we are talking about something different. So you would have seen some of the terms whatever I am mentioning here in terms of analytical method, numerical method, or probability and statistical method. So here you would have seen these terms like descriptive statistic, regression analysis, probability distribution, and time series modeling. Okay. So why this is different from other like divisions of mathematics? What is the distinction between that and this? Say, for example, I'm calculating the integration. Like x, I'm integrating that is x square by 2. The one, whatever that answer I'm going to get, is it certain or uncertain? We are certain, right? Whatever the number we are going to get, that is certain. So x value is certain, and then whatever number we are going to get is certain. So since this course is on hydrocarbon energy, So can I estimate rainfall? Certainly. Hmm? No. Which means what? Uncertainty that is coming out of what? So for example, here in this particular session I will be taking. Okay, this is defined already, which we can know before it occurs. But when we are having uncertainty means what? We have understood completely. No. So we have not understood completely, therefore there is a uncertainty. If you would have understood completely, then we don't need statistical or probability methods. Since we have not understood the concept or the mathematics behind any process, the rainfall we have not understood completely. So therefore there exists some uncertainty. So let us say there is uncertainty. So we don't know what would be the rainfall. There is uncertainty. In that case, you have two approach. One is you go to astrologer and ask, okay, what would be the tomorrow's value? Or you can do G Boomba and then say tomorrow's value. Those are it's like you can also do that, but the more scientific are the other approaches where we use methods which are developed when there is uncertainty in your data or when there is uncertainty in your understanding. We did not understand completely, therefore, so there exists uncertainty in the equations or in the data, so therefore we need some method which is better than going to astrologer or doing Jiguma. Okay. So now there are many subparts in probability and statistical method. We will see some of them are descriptive statistics, regression analysis, and these things I'll just introduce what is it. Okay, we are not going to discuss everything because this is a big mathematics division. So we will see what is it. The first one is descriptive statistics, which you generally know already. This we use when, let us say, you have rainfall which is for NIT Calicut, the rainfall which is for Bangalore. Okay. Let us say, how do you compare it? So if I wanted to compare, let us say if I wanted to compare one student with another student, how do I compare? In terms of, let us say, in academics. What do you look at? No, if I wanted to compare in terms of academics, marks. So do we look at every subject mark or every test mark? No. So we will calculate something called GPA and then we will be able to compare, right? So like here we wanted to compare different aspects. Okay, one is let us say different stations where is big and where is small. And like that, if I wanted to compare different parameters or same parameter at different points, so we use certain like index, or we call it as descriptive index. So which can be which would in a way say something. Okay, let us say if I talk about height of a person, it says the height. So that is the characteristics of a particular person. And I can also talk about weight and skin color and other factors, isn't it? All of them say some characteristics about that particular person, human being. So here we have data. So we need to characterize that particular data. In what way we can do that? So there are certain like index which would say which would quantify some characteristics about the data. So we will see one of them, and this we have already seen. Why do we need the property and statistical method? Because we have not understood completely, there exists uncertainty. So first we will look at the descriptive statistics. In that there are so many indices, but we will see some of them. So first one is some index which measures the central tendency. Okay. So I talk about the GPA, average, which is a student you would have got F grade to S grade, but and an average you would have got some mark. That is what we call it as percentage or GPA, isn't it? So that is generally is a mean. There are other ways as well. The measures of central tendency, where we use mean, median, and mode, and we will see what is it. And then measures of variability. So where there are so many index available, we will just look at range and standard deviation. Then we will the measure of frequency distribution, where we will see some of the basic ways to understand how the distribution of particular data is. So first one is mean, median, and mode. So which talks about the average. The mean talks about the average performance or average rainfall value for Calicut and average rainfall value for Bangalore. So which, let us say if the average value is more, which means you expect more rainfall over there. Okay, but there are other ways also, like let us say if the person would have got mark from F grade to S grade, in both the sides he got equal amount of values. Okay, in that case the average would be around C, but in some students would have got more of S grade and less of F grade. The other other one would have got more of F grade, like grade which is closer to F and some less number of S grade. Okay, in those kind of situations, when you have uh, distribution or the data is spreading over like this, where more than one central tendency, we use median and mode. Okay, the average is okay, but in addition to that we also use median and mode. Mode is like what is the value which is occurring more number of time. Okay, you would have got C grade, or in terms of rainfall the 30 mm would have occurred more number of time. So then median is, let us say if I sort the data or the grades or the rainfall values, then whatever is the center, okay, that is generally called median. So where do we use which one? It depends upon the situation. Just generally mean would work. So if I wanted to compare in detail, then I would go for median or mode. So this just talks about the mean or median. Let us say a particular city, the rainfall would be varying only from 25 to 35. In that case also you have mean around 30. One another city, the rainfall may be varying from, let us say, not 10 to 40 mm. Okay, in that case also mean could be near 30. Okay, in terms of even the student's mark, the student would have maybe scoring only D, C, B, or he may be scoring from the last value E to S. Okay, so the mean or the median or mode doesn't say how, what are the different values that particular person has taken or particular variable has taken. It just says what is the average performance, but it doesn't say what is the minimum value that it has taken or what is the maximum value that it has taken. So if I wanted to know, okay, let us say this will be useful when we wanted to see the consistency of the model. Let us say the student performance itself. There is one student who is always secure B grade or A or B grade. There is one more student, sometime he is secure S grade, sometime he will secure E grade, which is very close to F grade. So which one do we rely on? Which student do we rely on? Okay, who is more consistent when compared to the other person? So if I wanted to understand those aspects, okay, I have two models. Okay, the error of the climate model that is simulating rainfall or runoff, and error of the model. In one model the error is varying only between minus 0.5 to plus 0.5, the other but the average is 0. The other model, they are also having average of 0, but the error value is varying from minus 3 to plus 3. So which one should I choose? So if I look at only the mean value, then I don't have any say that both are having same mean value of 0 error. But which one should I choose among those two? Then I should go for the measures of spread or variability, where we talk about the range is the difference between the maximum and minimum value, or the standard deviation or variations, which talks about how the values are spread around the mean. Okay, so whether are they close to the mean or are they going far away from the mean, that can be quantified using standard deviation or variance. So the range just says,
like what is the minimum value and what is the maximum value. The difference in minimum and maximum value can be quantified in range. So this we will use when your mean remains same. Then if you wanted to compare two different models or two different stations, you go for the variabilities as well. Now I wanted to understand the complete behavior of the particular variable. So mean is okay, standard deviation is okay. I'm comparing in terms of mean and standard deviation, but I need to know the complete behavior. What is the, how the values are varying. Where do I expect more number of value and where do I expect less number of value. So if I wanted to understand the complete behavior, then I need to see some other statistics that is also descriptive in nature. So which talks about the measure of frequency distribution. The first one is the histogram. Okay, histogram is this one. What we do is we divide the data into number of divisions. Let us say 10 to 20. Between 10 to 20, how many values are recorded? So that we will plot. And then 20 to 30, 30 to 40, 40 to 50, like that. So then we will know where can we expect more number of values. Okay, let us say if I have, let us say 10 to 20, then how many values are expected between 10 to 20. Okay, this is a complete behavior of a particular data set or particular variable or a particular person. So I can even plot the CGPA or sorry grades obtained in each subject, and then I can plot an histogram of it. So which talks about how many times he got what is that C grade, or how many times he got B grade, or how many times he got F grade, and all of them. The complete behavior of the particular person we can understand, or we can try to understand, like using histogram. But the difference between the probability distribution and histogram we will see little later. But histogram, it's not a mathematical equation, it's just a graphical representation. Okay, and the other way to understand the complete behavior is the box plot. So we there also, it's like instead of showing like this, I will see what is the minimum value, what is the maximum value, and what is the spread, and all of them I can put it in one particular graphical form that we will call it as box plot. So the box plot would be something like this. So here uh, you have the Q1 and quartile 1 and quartile 3. Then the median is given here. So let us say if the size of this particular the interquartile range, this is called Q3 minus Q1 is interquartile range. If it is, let us say, very small, which means most of the values are in very narrow range, like which means the person got all the time C grade or something like that, or the value of rainfall is all the time around, let us say 30 or 40 or whatever the number. So if the size of this box increases, which means the spread of the data is increasing, the values are spread around the mean more than when the size of the box is small. And this, okay, this is interquartile range, and this point, this is upper whisk and this is lower whisk. This is not a minimum and maximum value. This is calculated using this one, Q1 minus 1.5 times the interquartile range. So if any number which is below or above, we generally call it as uncertainty. That would have occurred most probably because of let us say if we are talking about rainfall or some other, let us say, error measurement, that there we have to look at those values because that could have occurred because of some error or some other issues. Okay, so generally we say in this way. So this box plot is also one more way to understand how your, let us say, data set is behaving. Okay, the behavior of that particular data set. So rainfall of that particular station or temperature of that particular station. So the first way is to compare with mean, then standard deviation or range, then we can understand the complete behavior with either histogram or box plot. Okay, these are the basic descriptive statistics. So do you have any doubt as of now? No doubt. So we will move on to the next applications of statistical method, statistical and probabilistic method. So which is very common, even like our all the machine learning models and then chat GPT and all of them are based on this. Okay, so here what we are trying to do is I need to predict something. Okay, I need to calculate, let us say, the area of this particular room, okay, which is function of length and breadth. I have a complete understanding, and I also know the proper equation, that complete equation, length multiplied by breadth is the complete equation. I know I'll be able to estimate. But now whatever I wanted to predict, I don't have complete understanding. And the second thing is, I simply know that it is function of length and breadth, but I don't know how much length would be contributing and how much breadth would be contributing. And I measured values at one point, it says some number, and I measured values at another point, it says some other number. Okay, it's not universally same number. So it's generally we estimate runoff, which is a function of rainfall. Okay, so how much the rain, let's say runoff is equal to 0.2 of rainfall, or 0.3 of rainfall, or 0.4 of rainfall, or 0.9 of rainfall, or 1.5 times of rainfall, that we don't know, isn't it? So that number changes with respect to the place also. So here we are not certain about how much of rainfall is contributing to rainfall. It depends upon the watershed size and then characteristics and all those things, isn't it? So here physics we don't know completely, and in that case I need to build a model. Okay, a model where I need to estimate runoff from rainfall. I don't understand the physics and all. Okay, I don't know the physics behind it. I just have the rainfall data, I don't have the runoff data, or I need to calculate those things. So in those cases, let us say if we have clear understanding, that is the basic, they are connected. Okay, rainfall and runoff are connected. So in that case we can estimate from estimate runoff from rainfall. So in those cases we use a technique called regression, where we estimate one parameter from another parameter. Okay, the other parameter we know the value, we wanted to know, estimate a parameter for which we don't know the value. So here there are different ways through which we can do that. That is linear, this is generally called a regression analysis, where you do you estimate one parameter from another parameter. It can be more than one as well. Okay, so if the relationship whatever we are trying to build, if it is linear, that is you have only one option, that is straight line. If it is linear in nature, then it is called linear regression. Okay, it could be simple linear regression or multiple linear regression. If let us simple linear regression means we are estimating runoff only from rainfall. Let us say I can also include other parameter which influences runoff, let us say temperature or some other parameter. So but I am interested in creating a linear relationship, not the non-linear relationship, then it is called linear regression. Let us say that linear relationship is valid only in a certain cases. Okay, so if I am interested in let us say annual rainfall and annual stream flow, in that case the linear relationship may work. But if I am looking for like monthly or let us say daily values, then the kind of relationship that they have will be totally different. They will not have a linear relationship. Just because this increases, that does need not increase. The way rate in which that increases also will be different. Let us say in the daily rainfall, first let us say for first 5 mm or 10 mm rainfall will go as infiltration. Only after that it will convert into runoff, isn't it? So for first 10 mm the relationship is different. For the next 10 mm the relationship is different. For the remaining 10 mm the relationship is different. The relationship doesn't remain constant with respect to different values of the variable, then it can have kind of a non-linear relationship. We call it as there is a non-linear relationship. If the non-linear relationship can be quantified, let us say y is equal to e to the power x, which is a non-linear function. If we can quantify it, then we can go for simple non-linear regression equations. But the nature in which our variable exists, they we cannot quantify them in terms of a simple equation. Okay, it's in terms of e to the power x, or into the power in terms of sine x, or in terms of this way. So it is, even if it has to be this is called e to the power x, even if it has to be like that, so we know how it will behave. Okay, but if it is so dynamic, we don't know when it will behave this way, that way, that way, that way, like our mind, isn't it? Our mind fluctuates like anything. One If you are in this class, you behave in one way. If you are in another class, you behave in other way for the same content, isn't it? So if you are totally non-linear and we cannot come up with such any equation to uh, define that non-linearity, then we have other methods like machine learning based methods, where what it does is we use the data. From the data itself, we will try to build the function, okay, build the relationship. It could be like the kind of this line, or it's kind of a line which cannot be described in any mathematical equation, okay, which is we do it in a other way, like in terms of neurons or some other factors. So those are machine learning techniques. So the generally used things are ANN is quite old, so these days like we use generally LSTM based like regressions in most of our climate change studies are in water resource engineering field. So ANN means artificial neural network, KNN is K nearest neighbor, and SVM support vector machine, and LSTM. So this is one area. So here what we are doing is we are estimating one parameter from another parameter, okay. The another parameter is called independent variable. The parameter which we estimate is called dependent variable. But we done normally we don't we let us say if I wanted to estimate the dependent parameter, I need to know the value of independent parameter, isn't it? I need to have the access of that. Let us say if I don't have the access of that, then what should I do? Again go to astrologer? hmm? No, what can we do? Now I know that it's like one variable is dependent on the other variable, but when we have access to both the variable, then we do the regression equation. Now I don't have the other variable, that independent variable. I don't have access, just because maybe it is not recorded or something like that, but still I'm interested in predicting or forecasting, okay. There is missing data, or I wanted to estimate what is the next value. So in that case, what can we do? So for that also people have developed some methods where what we do is we estimate one parameter from the same parameter, okay. There with that techniques we call it as time series modeling. So where we understand how the time series behaves, what are the component of a time series, like a trend, periodicity. Let us say if it is sine wave, means it is a periodic time series. So it can be like what is the trend value one, what is the periodicity value, and what is the random component value, and if there is any jump, all those things if we can define it, then we can build some models, something like a Markov model, which is where you have a periodicity which is based on just previous value. That model can be used to estimate the next value or forecast the next value, okay. That can be used in terms of, let us say, yearly rainfall or yearly stream flow in those cases. But you have a time series which is something like this or more complex than this. Here you don't know what is the periodicity exist, or what is the trend exist, and where is the what is it jump, and all those things you don't know. So even in that case, there are different ways through which we can do it. Obviously, like like here also we can use machine learning technique like LSTM to estimate, let us say, runoff from the runoff itself, okay. That is one way where we don't understand the physics. That is completely black box model where we don't know anything, okay. Just we just have rough idea that they are connected, but how they are connected, that we don't know. But instead we are also have some other model like auto regressive model, where regression is based on the same parameter, the previous value of it's the same parameter. That is auto regressive model. If I want to improve the performance of that, then I can start in adding moving average component as well as the integration differentiation component. So then it is called ARIMA model, auto regressive integrated moving average model. So where we do the when we this uh, that will be useful when the time series having a non-stationarity, okay. We do the differencing. Then this one, frequency domain analysis, this is not a method to model the time series. It's kind of a way to understand the components of the time series, especially the periodicity that exists in a time series can be better quantified if we convert the time series from time domain to frequency domain. So that is like if we convert the time series into frequency domain, therefore we better understand the time series, and therefore we can better model the time series. So in the time series modeling, what we are doing is we are estimating the parameter, let us say the rainfall or runoff or whatever it is, from the same parameter. Now we will go to one of the wide applications that we have in let us say in hydroclimatology, that is probability distributions. Okay, it's risk assessment. So especially we use to do the risk assessment. If I wanted to understand the complete behavior of a variable, I've already told that there are ways to weave or ways to understand. What are they? In the descriptive statistics, I wanted to understand the complete behavior of that particular variable. I gave you some histogram is one thing, then box plot is one thing. So the histogram and box plot, we can see it, but can I write an equation for that? I can see that, but can I write an equation? Okay, this is the equation of this box plot. This is the equation for histogram. Can I write it? There is no way we can write equation for histogram or equation for box plot. We can just see it, but we cannot write, okay, at this particular point what would be the value, we cannot calculate from a particular equation. Okay, but what if, so probability distribution is again trying to say the same thing. It's trying to say the same behavior of the particular variable, but the difference here is we can write a equation for that particular behavior. Okay, any functions which has these two condition. Okay, so here the behavior means, like here what I'm talking about behavior means how much, like let us say rainfall less than 10 mm, how much, what is the possibility that it will take? 10 to 20 mm, what is the possibility that it will take? 20 to 30, what is the possibility that it will take? Okay, so we are talking about the possibility of a particular variable taking different values. So in that case, can the possibility go negative? Hmm? Can the possibility go negative? No, it can take only positive value, either 0 or above 0. The second thing is, can the total possibility can be more than 100? Let us say rainfall taking values 10 to 20, 20%, 20 to 30, 40%. If I add all of them, what should be the number? 100%. So any equation which satisfies these two things, that is, it gives values only above 0, and second thing is the total area under that particular equation is 1. We are talking about in terms of probability value. If any equation that satisfies these two conditions can be called as a probability density function. So there are different shapes in which the probability density function exists. There are how many possibility? There are so many possibilities. We can even develop our own probability density function as long as we just satisfy these two conditions. But in general, there are some probability distributions which are very popular. I hope you would have studied some. Can you tell some name? Hmm? Gaussian, normal distribution, log normal distribution. Okay, normal distribution you would have studied multiple times in your B Tech, M Tech, or wherever you go. They will not leave you with leave without you with a normal without normal distribution. They will not leave you. So what is this normal distribution? So why it is that famous or that popular? So if you look at behavior of variables, okay, I am talking about your height. Let us say your height values. Let us say height value of all the students in the NIT Calicut campus. I plot the histogram of it. Okay, I will get one particular shape, isn't it? Some shape I will get it, and like that I keep on working at different variable and its behavior. Okay, so error value or temperature value, this. So among different shapes that are possible, the one shape that like which is very common is the normal distribution which has a bell shaped curve. So error value, okay, if I'm calculating, let us say estimating stream flow, let us say from HMS model or some other model. So error value with respect to the observed value, see, we can plot how much is the error, okay, which like what is the average value and where is the minimum, what is the maximum, and what is the spread of it. The shape will become more or less this shape, okay, the bell shape curve. And there are many, even the height values, height of a different students in a particular campus and other parameters, most of the parameters will follow the normal distribution, and because of that it is quite famous. Then what are the other the issue with normal distribution is that it doesn't have any limit on both side, doesn't have any limit on x, like lower limit, there is no upper limit, okay. If there is a variable, let us say rainfall, it cannot take any value will below 0. So in that case the normal distribution is not applicable. In that case we need we need to choose a variable or distribution which better quantifies the distribution or behavior of rainfall. So it cannot be less than 0. In that case we can go for log normal distribution, which doesn't allow it, there is a one boundary, lower boundary is fixed, minimum value is 0, it cannot be less than 0. So like that there are different distributions that are available for us to use. So which, let us say I have a data, I am fitting into a distribution, but what is the use of that? I can see the behavior only from the histogram, isn't it, or from the box plot. Now what is the point in like writing a equation for that? I can see the behavior from the histogram itself, isn't it? Yes or no? Yes. Now I am interested in writing an equation for that behavior. Why I am interested? What is the difference? Why we are interested in this one? If I write an equation, what is the advantage I get? Hmm? Prediction? No. See, for example, here if I draw the histogram, in my case I may have values between, let us say, greater than 400 and less than 2400. Only that I know. But I have a sample that is maybe recorded only 100 years or 10 years or something like that. If I have access to, let us say, another 100 years of data, I may have values below 400 and above 2400, isn't it? But from the histogram I don't know what is the chance that it would take below 400 and above 400. But if I write a equation for that behavior, then I can simply substitute different x value and I can get what is the chance through which, like what is the chance that it will that particular variable will take. So we can do the extrapolation, the whatever is not observed in the particular data set can also be, for that also we can find the chances when we write equation for that, okay, for that particular behavior. So you would have studied many distributions, like we don't have time to discuss each and every distribution. The when we write an equation we will be also able to extrapolate outside the what values which we have recorded, but all of them for what reason? So I know what is the chance that the value rainfall will take between 10 to 20 mm. If I find that, what is the use? Our temperature between 10 to 20, like 10 to 10 degree to 20 degrees Celsius, our temperature above 35 degrees Celsius, I am finding a chance of temperature being above 35 degrees Celsius for kinetic aggregate. But what is the use of it? Hmm? Why we do need to know that? Extreme values, return, whatever you are saying, return period, okay, I understand. But why do we need all of them? Okay, I'll take an example. Let us say we have a drainage network, stormwater drainage network, okay. I can choose, we are not here talking about the structural design. I am not talking about the structural strength and all those things. I am just talking about the hydrologic design. where we are talking about the size of it. Okay, so I can choose some this much size or this much size, isn't it? Here I use a word called fail. Failure means when the capacity exceeds, I call it as fail. It's not like it's breaking. Okay, when the capacity of the drainage exists, which means we call it as the drainage has failed to drain the particular amount of water. So here I can go for this or this. Which one is having higher risk and which one is having lower risk of failure? Hmm? Which this is having high risk or low risk? Huh? Low risk of failure when compared to the smaller size, isn't it? So how much risk do I take to design this particular what is it, drainage? How much risk do you take? Is it a constant number? Let us say that I am constructing a drainage in NIT Calicut campus or near your house. You would have seen it's very small in size. But in airport, have you seen drainage? In airport, next to the runway, it would be more or less like a nala size. It will be very big. Why over there it is very big? Why in your house it is very small? No, it's not according to the capacity. So it's, see, where, why do we design? Let us say that your house is next to the airport, where you also expect same amount of rainfall. But why do your house drainage will be smaller than the airport drainage? Is the question. Based on the importance. Okay. Let us say that answer is correct. Let us say that I am in your house. Let us say in front of your house, the drainage is failing. At the max, what can happen? Your feet may get wet. Okay, that's what would happen. Let us say in the airport the drainage is failing, which means the capacity is not sufficient. We need more capacity. In that case, what would happen? We need to close the runway for whatever the time period that is needed for the water to go away, isn't it? So it depends upon the risk. Let us say if I wanted to construct a bigger drainage, means I need to spend more money, isn't it? But that money whatever I spend, is it worth or not, that we need to see. Even if my feet get wet for, let us say, 1 hour or 1 day, I don't mind. But if I close the airport for 1 day, what would be the economical loss? And I see the design life, let us say in 10 years, how many time I'll be forced to close if I do it in a smaller size. Then I choose low risk over there. So obviously, where it depends upon the importance of the structure. So when it is next to a very like a sensitive area, like nuclear power plant or airport or something like that, where we wanted to take as low risk as possible, or we also, it's like a play with money that is needed, or risk. Obviously we want to take zero risk, but if zero risk is not possible, even if I want to take 1% risk, the cost that is needed to construct that facility will be more. So we have to match these two. So this approach, calculating the risk for the particular, what is it, a variable. So what is, let us say I wanted to design bridge. What is the height at which I need to design it? So for that I need to know how much risk I am ready to take. So risk, if I say the word risk, what does it mean? Is it a daily risk or yearly risk or in their entire life? If I simply use the word called risk, what does it mean? How much risk? It doesn't quantify the time period, isn't it? So how much risk I am taking in a year, it says something. How much risk I am taking in a day, that says something. But simply risk doesn't say anything. Let us say the risk could be for the entire 1,000 year or so on. So here what we are interested in, we are just, especially when we are designing something like this, we are interested in calculating the risk in a given year. Per year, how much risk I am taking. Therefore, it is easy for me to fix or bargain. Therefore, everyone would understand. So the risk, how do we calculate it? There are different ways, but the one we generally do is called frequency analysis, where we connect the frequency versus the value. Okay, the frequency I also call it as in terms of risk. Okay, how do we connect them? The frequency of occurrence to the magnitude of occurrence. Let us say 10 mm per day. Once in how many days it would occur? I need to do it. I need to calculate it. So only then I would be able to calculate the risk. So if I want to design a, a bridge, let us say height of the bridge is 22 meter from the bed of the river. So how much risk do I have in a year? The water level in the particular river goes above 22 meter. Okay, that I need to calculate in a yearly basis. If I do that, then that will be useful. So then let us say if it has only 5% risk, then I need to choose a value which is having 1% risk. Then I increase the value. Okay, so here an approach which connects the frequency versus the value is called the frequency analysis. There it's like it is a procedure where we do that. But here I am talking about annual risk, which means in a year how much risk I am taking. For that, normally what we do is, let us say we have a rainfall value. If I take the daily rainfall value, our total rainfall value, that is from like 40 years or 50 years, and I can calculate, let us say for 1% exceedance probability, what is the value? Isn't it? I can take the daily rainfall value, and that I can create a curve, and I can write an equation for that, and I'm saying that the probability is 1%. For that 1% probability, what is the value? If I do that, what I'm trying to say is just for 1% probability the value, but it is, I'm not saying the 1% probability is per year or per month or per how many years, that I'm not saying. If I take the entire value, so generally what we do is we extract certain series called extreme series from the population or from the daily value. Let us say it could be annual maximum series, that is one value per year, and for that particular value we fit a distribution. Okay, then the minimum value in the annual maximum series, what is the exceedance probability? The minimum value, let us say I have 50 years of value, the annual maximum series, the annual maximum value varying from 500 to 1200. So the minimum value is having 100% risk, right? Every year the value is above 500. It's not exactly 100, it is near to 100 because we have only 50 years of data. The maximum value, let it could be 2400, it is having almost 0% exceedance probability. It is not exactly 0, it's almost 0, isn't it? So when we extract the extreme series, and after that we try to fit a distribution, and after that we calculate the, for the given probability, what is the value, and that probability would define the frequency. Okay, once in how many years. Let us say that there is a relationship called that is relating, if we take annual maximum series, the probability is equal to 1 by t. Okay, if I wanted to calculate an event that occurs once in 10 years, the probability of exceedance would be 1 by 10. Okay, if I wanted to calculate 100-year event, that is 1 by 100. So what if we have an extreme value series, then we fit a distribution. So here this distribution, it's not like we cannot use normal distribution and all. Here like we generally in hydrology we have a distribution called extreme value distributions, the type 1, type 2 and type 3, or we can also use some other distribution, depends upon the data. Generally we use the extreme value distributions. So once you fit the distribution, and after that for different probabilities you can calculate the value. So in this case, for 10-year return period, the rainfall value is 90 mm per hour, which means this area, the area on the right side of 90 mm is around 0.1 mm. So in this case, as of now, we are assuming this particular shape or curve to be constant for the entire duration of the life or for the future. Okay, I'm constructing this curve in this curve based on let us say 40 year or 50 year of data, and I'm assuming that particular curve to be valid for the rest of the years. Okay, this approach is called stationary approach, where we assume the curve to be constant, but due to climate change and all other factors, you know that already it's like the rainfall is keep on like changing and temperature is keep on increasing. So in those cases this curve may not remain same. So when the curve doesn't remain same, then the way in which we do is different. Okay, that is frequency analysis under non-stationary conditions. Now we don't have time to do that. So as of now, the frequency analysis means from the extreme series we come up with this particular the shape we will define from the once we define the shape, that is once we write the equation, after that for different probability value we can find the different return level that can be used for in various design aspects. So do you have any doubt? The statistical method, what are the things which you have discussed? Descriptive, then regression, then time series modeling, then probability distributions for the frequency analysis. These are the things which we have discussed. These are the major areas where we use the probability and statistics in hydroclimatology.